Oh, yeah. Pale blood. Well, you've come to the right place.
What do you see in this image? How about this one? Is it a rabbit or a duck? All of this starts with the eyes. First, the signal triggers an electrochemical impulse, which travels down the optic nerve to the back of the brain, the occipital lobe, where it's then processed by all of these very complex structures at the back of your head, named V1 through to V3. You can see V5 on the screen. Yes, it gets complicated, don't worry. The point is, V1, very simple processing of visual information. V2, slightly more complex. V3 and onwards, also complex. They all have very specific roles. There's another image here for you to look at. Here's another more specific location map of the areas of the occipital lobe. The idea is very simple. We have these bits of data that come from our eyes, that go to the back of our head, then they're processed by what are called feature detectors, and those feature detectors detect lines and curves, and then the higher level processing processes the rest of the information to form shapes. And Vsauce has a perfect illustration of this in his Stillwell brain experiment.
Pixels, and bam, the 13 retinal cells connected to those locations are firing. Now that's what I call a sensation. V1 reads the formation perfectly. They don't even know it, but each one firing means a horizontal, vertical, or diagonal line has been caught. Now look at neuron 4D's speed. It's sensitive only to a horizontal line low and to the right, which my 8 had. If retinal cells 23, 24, and 25 all fire together, such a line has been sensed. And watch this.
So I assume you get the idea. The people act as the different neurons involved in visual processing. This is a very small scale example. There are much more neurons in the brain than this, but the idea is simple. We pick up on these little bits of data and then we put it together in an image using signal detectors, and they reroute the impulses. And perception itself also has some more complexities, like you can see on screen. All these are circles and dots, but we detect shapes and groups and backgrounds and directions and all sorts of different things, because our brains are supposed to pick up on these things for us to figure out what's going on in the world around us. And we need a stimulus to be above 50% detection rate for us to notice it, essentially. You can see here why creatures dominate in our nightmares. This is getting back to the topic of Bloodborne. Agency detection, threats, simulation. You can see all the reference here. You can read it if you want. But we're supposed to detect these things. So when you see those ink blots, if you see creatures, for example, you know, that's the hyperactive agency detector at work there. And I mean, what is this? Like, look at this. How do you figure out what that is? You know, it's so bizarre. You have to really look at it for a while for you to figure out what's going on. You know, it's all just a blur until you really look and detect all those features. And I think this game makes very good use of that evolutionary psychology, and through practice we decrease our fear to these different creatures.
Ah, you found yourself a hunter.